Today we're going to talk about unmanaged versus managed switches, and then we're going to talk about spanning tree protocol. There is a whole lot of information to cover, not a lot of time, so let's jump into this session. I'm going to begin by talking about unmanaged switches and managed switches. Before we begin discussing the differences between unmanaged and managed switches, let's talk switch basics. Most switches operate at layer 2, the data link layer, of the OSI reference model. What makes a switch is an application-specific integrated circuit chip, or an ASIC chip. It is used to make switching decisions in place of software. This allows switches to break up collision domains. This allows switches to run in full duplex mode, and this allows switches to make faster decisions than either bridges or routers. When a switch receives a frame on a port, it makes some simple decisions based on its media access control table, or its MAC table. It will make one of three decisions. It may decide to forward the frame. That is where the frame is directed out the port on which the destination MAC address resides. It may decide to filter the packet. That is where the frame is not directed out of ports which are not associated with the destination MAC address. The final decision that it may make is to flood the frame. The frame is flooded or sent out all of the ports on the switch except for the port on which it came in on. An unmanaged switch is a simple switch. Plug it in and it works. There is no method provided for configuration. The unmanaged switch is designed with ease of installation as its main attribute. Managed switches, on the other hand, can be configured through either the command line or a browser-based interface. Managed switches provide for a high degree of network customization and control. A managed switch can also be set up so that an administrator can monitor its performance remotely and use protocols such as SNMP to make some modifications to its configuration. Now let's move on to spanning tree protocol. Spanning tree protocol is a loop avoidance technology. A switching loop can occur on networks where there are multiple paths to reach destination MAC addresses. Digital Equipment Corporation created the Spanning Tree Protocol, or STP, to reduce the possibility of switching loops. The switches elect a root bridge to control the switched network. The switches will shut down ports that are not the best path to the root bridge, thus reducing the risk of loops. No network traffic can flow until after the STP process has taken place and a stable state has been achieved. This stable state is called convergence, and it can take a significant amount of time with STP, up to 50 seconds. After convergence, the STP selected switch ports send out Bridge Protocol Data Unit packets, or BPDU packets, to help maintain the stable state. All switch ports in an STP-enabled network can be in one of 5 states. First off, there is the disabled state. That is where the port is administratively shut down. It's not receiving packets, it's not sending packets, it's just completely disabled. Then there's the blocking state. In this state, the port will not forward packets, but it's still receiving BPDU packets and will drop all other frames. Then there's the listening state. In this state, the port will not forward packets, but listens to BPDU packets to make sure that no loops can occur in preparation for the next state. Then there's the learning state. In this state, the port will not forward packets, but it is learning all of the paths in the network. It is populating its MAC address table in preparation for the next state. The last state in Spanning Tree Protocol is the forwarding state. In this state, the port will forward and receive all packets that are flowing across the network that are directed to that port. The IEEE liked STP so much that it created the 802.1d standard. This is their version of STP. All modern Layer 2 switches run the 802.1d standard by default. The slow convergence time of the 802.1d standard led to the creation of Rapid Spanning Tree Protocol, or RSTP, which is also known as the IEEE 802.1w standard. RSTP has a much faster convergence time than 802.1d. With RSTP enabled on all switches, a network can achieve its stable state in approximately 5 seconds. That's a whole lot faster than the up to 50 seconds with the 802.1d standard. But RSTP is not turned on by default on Layer 2 switches. It must be enabled by an administrator. Instead of 5 possible port states, RSTP defines 3 possible port states. The first of these states is discarding. In this state, the port may be administratively disabled, or it may be in a blocking mode or listening mode. The next state is learning. In this state, the port is populating its MAC address table in preparation for forwarding packets. And the final state is forwarding. In this state, the port is actively forwarding packets. Now that concludes this session on Configuring Switches Part 1. I talked about unmanaged versus managed switches, and then I had a brief discussion on spanning tree protocol. Today we're going to discuss installation considerations, and then we're going to move on to configuring the switch port. There's a fair amount of ground to cover, so let's go ahead and dive into today's session. Of course, I'm going to begin with installation considerations. The first installation consideration is whether or not you need a managed or unmanaged switch. The business or enterprise network is more complex than the small office, home office network. A SOHO network may be able to get by with using one or more unmanaged switches and still operate adequately. But once beyond the level of a SOHO, more thought and planning is required, as unmanaged switches are no longer up to the job. You are going to need managed switches. There are multiple issues to consider when installing a managed switch, and it is wise to plan for those in advance to save both time and frustration in setting up a network. One of the first things to consider is if there will be VLANs, Virtual Local Area Networks. While switches may break up collision domains, they do not break up broadcast domains. But VLANs will. A virtual local area network takes a single network environment and creates smaller network segments by subnetting the network address range, effectively breaking up the broadcast domains of that network. VLANs are used in a switched network environment for a variety of reasons. To break up broadcast domains into smaller segments, just like I just said. Another reason to use VLANs is they increase security by limiting access to network resources. The administrator configures the VLANs and then assigns users, nodes, or ports to a specific virtual local area network. All managed switches do come with a native VLAN, which is determined by the manufacturer. This native VLAN is used to help manage the switch. VLAN traffic is allowed to cross switch ports as long as the VLAN information matches. So VLAN 2 can send traffic to VLAN 2, but VLAN 2 cannot send traffic to VLAN 3. VLAN traffic is allowed to cross switch ports as long as the VLAN information matches. It does this through the use of trunk ports. That means that VLAN 2 can send traffic across a trunk port to VLAN 2, but it cannot send traffic from VLAN 2 across a trunk port to VLAN 3. VTP, or Virtual Trunk Port Protocol, is a Cisco proprietary method of creating a virtual trunk port, which allows VLAN traffic to pass between switches and to automatically manage the VLAN environment. In order for different VLANs to communicate with each other, a router or some other Layer 3 device must be installed on the network. The next consideration is, how is the switch going to be managed? Switches may be managed out of band. That means that no network connection is required. This is achieved through the use of the console port on the switch. The console port is a specific port on managed switches used to connect to and configure or manage a switch. A rollover cable may be required to make the connection to the console port. Security should also be set on console ports to prevent unauthorized access through that console port. Your other option for switch management may be to use in-band management. With in-band management, a network connection is used to manage the switch. One of the most common methods of allowed in-band management is through the use of virtual terminals or VTY connections. The most common VTY connections are Telnet or Secure Shell Sessions, SSH sessions. Security should also be set if Telnet is allowed on VTY type connections. By default, SSH is a secured connection. If you determine that you're going to use in-band management, the next thing that you need to do is to establish a default gateway address. That default gateway address must be placed on an interface that belongs to the native VLAN, or the default virtual local area network. The default gateway on a switch is different than the default gateway on a router. On a switch, it is only used to manage the switch and not to pass other network traffic. As part of the setup and management of the switch, an administrator should configure which users and passwords are allowed to connect to the switch and what their level of access to the configuration is going to be. In-band and out-of-band management security settings may be different. Some users may be allowed in-band management access, while others are not, and vice versa. If authentication, authorization, and accounting protocols are used in the network, the switch must be configured to use them as well. With that done, let's move on to configuring the switch port. I'm not going to actually show you the commands for how to configure the switch port, but I'm going to give you the information that you need to consider when configuring the switch port. First up is speed and duplexing. Most modern switch ports can auto-negotiate both the speed of the link and the duplexing mode used. But in some cases, an administrator may be required to manually set both the speed and the duplex in order for a connection to occur. Speed and duplexing errors are the most common cause for a link not being established between a switch and a router or between switches. Next up is VLAN assignment. All switch ports will belong to a VLAN, and that VLAN will either be an administrator configured one or it will be the native virtual local area network. As a side note, the native VLAN can be administratively changed, which should be done to increase the security level on the switch. Then there's trunking. Trunk ports are switch ports that are designed to carry VLAN traffic between switches. The standard protocol used is 802.1q. 802.1q strips off the VLAN tag. Actually, it changes that tag to match the native VLAN, which allows the traffic to cross over the port, and then once on the other side, then the 802.1q port on the other side reinserts the original VLAN tag. And that is trunking in a nutshell. You might want to consider port bonding using LACP. That's Link Aggregation Control Protocol. It is a protocol that is used to create a single logical channel from redundant connections between switches. So it bonds those ports together. This will increase the bandwidth between the switches. Now we're going to talk about PoE. Not Edgar Allan Poe, but Power over Ethernet. Some switches come equipped with Power over Ethernet ports, or PoE ports. These ports can use one of two methods to provide current over the network cable, as well as carrying data, allowing these ports to power small network devices while at the same time communicating with them. The port itself may provide the current, or the port may allow the use of a power injector to provide the power instead of the port itself. There are multiple PoE standards in place. The two most common are actually the PoE standard, the 802.3AF, which can provide up to 15.4 watts of current, or the PoE Plus, which is 802.3AT, which can provide up to 30 watts of current. Port mirroring may also be enabled on a switch port. This allows the configured port to receive all network traffic going to and from a specific port. By using port mirroring, an administrator can examine and analyze the traffic going into and coming from a specific host or port. Port mirroring is most often used in conjunction with a packet analyzer, also known as a packet sniffer or network sniffer. Administrators often use port mirroring to examine the flow of traffic to determine what method of network optimization to use, or for when they're determining which security measures to put in place. Port mirroring can create a significant amount of network overhead, so it should be used sparingly on an active network, and you may want to shut it down once your research has concluded. That concludes this session on configuring switches part 2. I talked about installation considerations, and then I talked about configuring the switch port itself.